This is a short video showing how we can incorporate the use of organometallic reagents in a synthesis problem. And so when I see this synthesis before me, I see 2 carbons in my starting material and I see 4 carbons in my final product. I realize that most likely I will be using an epoxide. Remember, it's that 3-membered ring with the oxygen as a way to add 2 carbons to my starting material. But then I think about that and I know that in order to pull that off, I'm actually going to need a negatively charged carbon to couple those 2 together. And so the way that I would do that from this set of chapters would be using an organometallic compound. However, if I look at my starting material, I see that it's an alcohol. And from the alcohol chapter, we remember that that's pretty unreactive. And so in order to create my organometallic compound, I'm going to need to convert that alcohol into something that's a little bit more reactive. And so the way that we're going to do that is we're going to use SOCl2 in pyridine, and that's going to convert it to the alkyl halide. Now, in order to make my organometallic reagent, I'm going to react that alkyl halide with lithium and hexane to get the lithium compound. And in order to make my cuprate, the next step would be reacting that with copper iodide, which will give us the cuprate, the organocuprate, which is this ethyl group taken twice with copper lithium. Now, that creates our negatively charged carbon, which then we're going to react with our epoxide, followed by treatment with acid to protonate. And then that gives us our alcohol. So this is just one example of how we could use an organometallic in the synthesis problem. Hope this helps. Good luck.